rounding out the basics of object-oriented programming in Python. By now, we have a good idea of what object-oriented programming is, even if it still seems like a relatively new concept. We know about classes, we know that they have fields and methods, and how multiple separate objects can come from one class. We've also taken our first look at how OO is done in Python. How a special method called the constructor, or init, short for initializer, works, how we define it, and how we use it to instance new objects of a class. We're going to explore in greater detail the different fields and methods a class might have, and what they might be used for, and crucially, how we can implement them and use them in our own Python code. First thing we'll look at is how we define methods and call methods for a class, beyond just the constructor, of course. Once we understand the constructor, moving on to other methods shouldn't be too complicated, as the syntax is mostly the same. Let's see this done with our student class from last time. The def keyword is still used, and we still need to include the self as the first parameter. However, we can give the method whatever name we want, just so long as it doesn't clash with any others in the class. Calling it is also very simple. This is mostly the same as calling any other function, only this time we need to specify which object we're calling it for. If it looks like we're missing a parameter, remember that we don't need to explicitly pass the self parameter for methods in Python, as this is done automatically. Let's add a bit more. We don't just want the student to say hello, we also want them to introduce themselves with their name and year of study. Here's how we do that. It's as simple as calling fields by name, which we defined in the constructor, remembering to use the self.dot syntax. If you're wondering if these fields have been defined yet, remember that by definition, the constructor is the very first thing that is called when an object is created. If we're calling any other method from an object, then that means the constructor must have run, otherwise we wouldn't have an object to call from in the first place. So long as the field has been defined in the constructor, we can reference it later at any time. Methods don't just refer back to an object's properties, they can also change them. Let's define a continue year method, which will increase the student's year of study by 1. When run, this will overwrite the self's year property to be its original value plus 1. Beyond that, class methods are pretty much just like any other function. They can take any number of parameters, including keyword arguments, of any type, and they can return a value. They can even call on other functions and methods themselves. Now, we've seen how we can define and access class fields or properties for classes in Python. So far, it's been pretty simple. We define a field in the class definition, we write our constructor such that it takes an argument for that field, and then every time we run the constructor, we pass in the values we want. But don't get the idea that there is a strict one-to-one relationship between properties and constructor parameters, because this is not always the case. To illustrate how this can be different, we'll introduce an entirely new example. Let's define a class to represent a 2D square with a single property for its area. You may be imagining a constructor that looks something like this, and you wouldn't be wrong. This is a perfectly good solution, but it's not what I want to show you for this example. As you probably know, the area of a square can be calculated as the length of one of its sides squared. We can define a constructor that does exactly this, takes a parameter for length and calculates, using that length, the area. This proves our point. The constructor for this class takes a parameter which is not directly stored as a field. Similarly, the area property is not directly given as a parameter. Instead, it is calculated based on the parameters given. We can't go on to reference the property of the square.length because that property doesn't exist. We never actually saved it. We only used the length as a parameter for the constructor. It's also not uncommon for classes to assign default values to certain fields in the constructor. We can tweak our earlier example so that students always start with a default value of 0, the year of study. See that the year parameter has been removed altogether, but the self.year property remains and is assigned the same value each time. But this doesn't mean the value has to stay 0 for the lifetime of each object. We can see this by just using the continue year method we defined earlier. This pretty much covers the basics of OO in Python, although we've only just scratched the surface of how we can actually apply them. Again, practice is key. Having a play around and doing some simple challenges with what we've discussed is a great way to digest and understand these concepts. In the next few sessions, we'll be exploring passing by reference versus passing by name, how they're different, and when each is used. Then we'll move on to some more complex uses of objects, such as interaction between multiple classes.